Well, we are here to obviously talk about the GOES S. I know we were excited about a year and 4 months ago about GOES R, now GOES 16 launching. But what makes the GOES S significant? How will it improve weather forecasting, Vanessa?
Well, I think that the advantage of having now two satellites in orbit with the same technology, the same advanced capabilities that we've already seen now with GOES 16, is by having two, we have a full coverage of the Western Hemisphere. So we'll be able to see weather systems with the kind of detail and the kind of high refresh rates that we get from the new GOES-R satellites over the Pacific. So certainly understanding the weather systems that are to our west as they're moving in is very important for improving our weather forecasting. So having the two satellites, having a complete coverage of the hemisphere from both GOES East and GOES West is going to be very important and very beneficial to weather forecasting.
Yeah, because many weather forecasters will note that the weather starts out west and it works to the east. And here in Florida, we have two significant weather phenomena that happen all of the time: fog and lightning. Specifically, how will GOES S help us with that forecasting?
Well, let's talk about lightning first. So for the first time from a geostationary platform, we will have lightning data from a satellite. We've flown satellites in the past at lower altitude with lightning, but this will give us a look at the lightning, like this image here, over the United States, both at night and during the daytime. And we have not yet begun to really fully be able to determine how benefit that's going to be. We're seeing advantages already of tracking storms. We think they're lightning signals that will help us improve storm detection as well as storm forecasting for convection. Fog, of course, the advantage of GOES-R, the GOES-R series satellites and now GOES-S, is that we get the data more frequently and we get more information and we get it much higher resolution. So we'll do a better job of being able to forecast when fog is lifting or dissipating. We've already seen that with GOES 16, for examples of when we were able to remove a fog warning or a fog hold on an airport early by using the information from GOES 16.
Incredible. And there are actually some economic benefits as well.
Well, obviously, tropical storms and providing better warnings, providing very focused warnings, very important. Well, obviously, saving lives and property is what weather satellites is really the benefit of them to the nation. So we'll see those benefits, but we'll also see advantages both in fighting forest fires and determining air pollution, monitoring from fires, a lot of other advantages, as well as, of course, just monitoring severe weather and giving the nation a little more advanced warning of things so they can prepare.
Okay, for the folks at home, geostationary satellite, what exactly is that?
All right, so we actually have two kinds of satellites that NOAA operates, both polar orbiting satellites and geostationary. The geostationary ones, if you think about the Earth and the satellite's at 22,000 miles out. Where that is, the speed of that satellite as it's revolving around the Earth exactly matches the speed of the Earth turning. So in effect, what it looks like is that the satellite never moves. It stays right over the same place over the Earth. By having a satellite do that, we're able to then watch the clouds and the storms beneath the satellite and see where they're moving in that frame of reference. So it gives us this great frame of reference. It gives us these wonderful movie loops like the one you're seeing here of the storms as they're developing, as they're moving, as they're coming on shore in the case of hurricanes. All this information, this real-time video of the storms is what's so beneficial from geostationary satellites.
Indeed, and I will be there at the launch next Thursday. The satellite will go into the air next Thursday, obviously, but when will it actually be operational? When will we have the data to look at?
So we'll launch GOES-S next week. As soon as it gets to orbit and gets stable in its orbit position, we'll label it GOES 17, so then we'll start doing all of our post-launch testing. It takes about 6 months to really check out the satellite, the systems, the instruments, make sure everything's working, making sure all the products that we've already starting to use from GOES 16 work the same on GOES 17. It takes about 6 months. And then so later at the end of the year, we'll actually then move the satellite, GOES 17, into its operating position as the GOES West satellite.
And finally, Vanessa, we talk about all of the video channels that will be available, or the channels that we will be able to see different types or different levels of imagery. Explain that to the people at home.
Well, we have the satellite itself, the primary instrument on board has 16 channels of information. So we use that. We can manipulate the information from those channels to determine things, unique things that we couldn't determine before about the environment, about the atmosphere between the satellite and the Earth. And of course, we'll have various venues of putting that data out so that people will get a hold of that data and be able to use it in near real time.
Vanessa, incredible. We are definitely excited to hear in Florida about the launch, and I will be there, and we look forward to learning more and seeing these images when they become available. Thank you for joining us.
You're welcome, and have a good launch viewing. I know it's going to be a great day.
Thank you.